The SY/MAX50 Programmable Logic Controller, or PLC, represents an earlier generation of industrial control technology. These PLC were primarily manufactured and supported by Square D, which later became part of Schneider Electric. Understanding the SY/MAX50 involves recognizing its role in automating processes, particularly in applications such as car park lift systems. While specific details about the SY/MAX50 may be scarce due to its age, we can infer several key aspects based on general PLC principles and available documentation for similar systems of that era. The SY/MAX50, like other PLC, functions as a digital computer designed for real-time control of electromechanical processes. Its core components typically include a central processing unit, or CPU, memory modules, input and output, or I/O modules, and a power supply. The CPU executes the control logic programmed into the PLC. This logic dictates how the PLC responds to inputs from sensors and other devices and generates outputs to control actuators, motors, and other equipment. Memory modules store the PLC operating system, the control program, and data related to the control process. I/O modules provide the interface between the PLC and the external world. Input modules receive signals from sensors such as limit switches, pressure sensors, and proximity sensors. Output modules send signals to control devices like motor starters, solenoid valves, and indicator lights. The power supply provides the necessary electrical power to operate the PLC various components. The programming of SY/MAX50 PLC would typically involve using a dedicated programming software package, often running on a personal computer. This software allows the engineer to create and edit the control logic using a graphical language such as ladder logic, function block diagrams, or structured text. Once the program is written, it is downloaded to the PLC memory for execution. Considering the age of the SY/MAX50, several challenges may arise when attempting to maintain or repair such systems. Firstly, spare parts may be difficult to obtain or no longer available. Secondly, the original programming software and documentation may be lost or inaccessible. Thirdly, the technical expertise required to troubleshoot and maintain these older PLC may be limited. Given these challenges, a common approach is to replace the outdated SY/MAX50 PLC with a modern PLC system. This involves selecting a new PLC platform, rewriting the control logic, and rewiring the I/O connections. When choosing a replacement PLC, it's important to consider factors such as the number of I/O points required, the communication protocols supported, the programming language used, and the availability of technical support. Popular PLC brands include Allen Bradley, Siemens, and Modicon. These manufacturers offer a wide range of PLC models to suit various applications. The process of replacing the SY/MAX50 PLC typically involves the following steps. Firstly, documenting the existing system. Before removing the old PLC, it's crucial to thoroughly document the existing system. This includes creating a wiring diagram of all I/O connections, recording the PLC program logic, and noting any relevant operating parameters. Secondly, selecting a replacement PLC. Based on the requirements of the application, choose a suitable replacement PLC model. Consider factors such as the number of I/O points, communication protocols, and programming language. Thirdly, designing the new control panel layout. Plan a layout of the new control panel, taking into account the size and mounting requirements of the replacement PLC and other components. Ensure that there is adequate space for wiring and maintenance. Fourthly, wiring the new PLC. Disconnect the wiring from the old PLC and reconnect it to the new PLC according to the wiring diagram. Use proper wiring techniques and ensure that all connections are secure. Fifthly, programming the new PLC. Rewrite the control logic from the old PLC into the programming language of the new PLC. Test the program thoroughly to ensure that it functions correctly. Sixthly, testing and commissioning the system. After wiring and programming the new PLC, thoroughly test the system to verify that it operates as intended. commission the system and train the operators on its use. When upgrading a control panel, it's essential to adhere to relevant electrical codes and safety standards. In the United States, the National Electrical Code, or NEC, provides guidelines for safe electrical installations. Chapter 3 of the NEC covers wiring methods and materials. Article 408 addresses switchboards, switchgear, and panel boards. Article 430 covers motors, motor circuits, and controllers. Article 500 through 516 address hazardous locations. Article 670 covers industrial machinery. Article 690 covers solar photovoltaic systems. Proper grounding and bonding are crucial for ensuring electrical safety. The NEC requires that all metal enclosures and equipment be properly grounded to provide a low impedance path for fault current. This helps to prevent electrical shock hazards and equipment damage. Grounding is typically achieved by connecting the metal enclosure to a grounding electrode, such as a ground rod or a building steel structure. Bonding involves connecting all metal parts of the electrical system together to create an equipotential plane. This helps to minimize voltage differences between different parts of the system, reducing the risk of electric shock. Overcurrent protection devices, such as circuit breakers and fuses, are essential for protecting electrical circuits from overloads and short circuits. These devices are designed to interrupt the flow of current when it exceeds a predetermined level. The NEC specifies the required overcurrent protection for different types of circuits and equipment. For example, Section 430.52 of the NEC provides guidelines for sizing overcurrent protection for motor circuits. The size of the overcurrent protection device depends on the motor's full load current and the type of motor. In addition to overcurrent protection, surge protection devices, or SPDs, can help protect sensitive electronic equipment from voltage surges caused by lightning strikes or other disturbances. SPD are designed to divert surge current to ground, preventing it from damaging the equipment. The NEC recommends the use of SPD in certain applications, such as in buildings with sensitive electronic equipment or in areas prone to lightning strikes. When working with electrical equipment, it's essential to follow safe work practices. These practices include energizing circuits before working on them, using appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses, and following lockout-tagout procedures to prevent accidental re-energization of circuits. Lockout-tagout procedures involve disconnecting the power source to the equipment and attaching a lock and tag to the disconnecting means to prevent it from being turned on accidentally. Only authorized personnel should be allowed to remove the locks and tags. Regular inspections and maintenance are crucial for ensuring the safe and reliable operation of electrical systems. These inspections should include checking for loose connections, damaged wiring, and corroded components. Any problems identified during the inspection should be promptly corrected. Maintenance tasks may include tightening connections, replacing worn components, and cleaning equipment. When replacing a SY/MAX50 PLC, consider the communication protocol supported by the replacement PLC. Common communication protocols used in industrial automation include Ethernet, Modbus, Profibus, and DeviceNet. Ethernet is a widely used communication protocol that allows devices to communicate over a network. It is commonly used for connecting PLC, human-machine interfaces, or HMIs, and other devices in an industrial control system. Modbus is a serial communication protocol that is widely used for connecting PLC and other devices. It is a relatively simple protocol that is easy to implement and use. Profibus is a fieldbus communication protocol that is commonly used in industrial automation applications. It is a robust and reliable protocol that can support a large number of devices. DeviceNet is a communication protocol that is based on the Controller Area Network, or CAN, bus. It is commonly used for connecting sensors, actuators, and other devices in an industrial control system. When selecting a replacement PLC, ensure that it supports the communication protocols required for the application. This will allow the PLC to communicate with other devices in the control system. In addition to selecting a replacement PLC, it's also important to consider the HMI that will be used to interface with the PLC. An HMI is a graphical user interface that allows operators to monitor and control the process being controlled by the PLC. HMI typically provide a visual representation of the process, allowing operators to see the status of various devices and make adjustments as needed. When selecting an HMI, consider factors such as the screen size, resolution, and the type of interface supported. Some HMI support touchscreen interfaces, while others use traditional buttons and switches. It's also important to consider the communication protocols supported by the HMI. The HMI must be able to communicate with the PLC in order to exchange data. Modern PLC offer advanced features such as built-in web servers, data logging capabilities, and remote access capabilities. Built-in web servers allow users to access the PLC configuration and status information using a web browser. Data logging capabilities allow the PLC to record data over time, which can be used for trending and analysis. Remote access capabilities allow users to remotely access the PLC from a remote location, which can be useful for troubleshooting and maintenance. When selecting a replacement PLC, consider whether these advanced features are required for the application. These features can provide valuable insights into the operation of the process and can simplify maintenance and troubleshooting. In summary, replacing an outdated SY/MAX50 PLC requires careful planning and execution. It's essential to thoroughly document the existing system, select a suitable replacement PLC, and follow proper wiring and programming procedures. Adhering to relevant electrical codes and safety standards is crucial for ensuring a safe and reliable installation.